Hello and welcome to another exciting Blender tutorial. Today we're going to be making lasers using geometry nodes. Let's get started. Special thanks to everybody on the Patreon who supports this channel and everybody on YouTube who has joined to support the channel there as well. Okay, so today the plan is to try and recreate the system that we had earlier in the Epic Space Battle series. If you've seen that, there's a section where we create some lasers using particles, and the particle, when it hits something, explodes into a shower of sparks. It was a really kind of complicated system and it didn't really work very well, to be honest. So I thought, let's reapproach the problem. Let's make something even better using geometry nodes, right? So let's do it. I'm going to go ahead and delete everything. And I'm going to Shift A and create another cube because I just deleted the default cube and I created another cube. What can I say? It's a tutorial. All right, next up, we're going to put geometry nodes on this guy. So let's go over to the wrench and let's come down to add modifier and let's add geometry nodes. Just clicking there and we're going to click new to create a new geometry node system. Now I was going to bring up our little timeline and I'm going to switch over to the geometry nodes editor and zoom right in. Looking good. All right, I'm going to come here and I will type lasers is the name of our geometry node system. And I'm just going to delete the geometry nodes group input because we don't need that cube. It's sort of like deleting the default cube again. Okay, so we're going to create two empties. First empty, I'm going to just drop it here at the origin. We'll call this laser start and we're going to Shift D and grab this one over here. This one's going to be laser end. This is going to be a mark sort of the beginning and end points of where our laser is going to travel. Now let's go back over to our cube with our lasers. I'm going to rename this cube to the laser system. And I'm going to pin it. I'm going to click that little thumbtack icon. This basically just means if I click on something else, we're always going to keep this up. We don't have to have this object active to see the laser system in the geometry nodes setup. So first we need to get the position of these two guys into our system. So I'm going to create a object info node. Just Shift A and then type in the search section. Click the search and click on object info. Do that again. Shift A, click search. And we're going to type in object info. There it is. Okay, so we got both of these. And in the dropdown, we're going to grab laser start and laser end. First thing we need to do is create a line between these 2 points. And we're going to use this line for sort of generating information about how the laser should travel. So the angle and all that stuff. So let's go down to curve primitives and we're going to create a curve line. And we've got a nice input and output for the curve line. So we're going to use the location of our laser start as the start point of our line and the end point of our line. You guessed it, the location of laser end. Bam. Now we're not going to see anything yet because we haven't plugged this into the output. But when we do, you'll see we get a nice line. And if I move my empty around anywhere, it's going to update and continue to draw the line between the 2 points, which is really cool. All right. Now we're going to create an instance on this point. And instead of just creating the laser object itself, I want to create an instance just in case we can figure out down the track how to have like multiple lasers traveling at once. I'm not quite sure how to do that, but we'll set this up like this just in case we can crack it. So I'm going to come over here and we're going to type in points. Now points it's like a particle kind of. We can instance objects onto those points. So we're going to get so we got count of 1. That's what we want. Now we need to set a position. So we want to sample this curve. There's this node here called the sample curve node. If we drop that in here, this will give us information about our curve at different points. We're going to switch this over to length because we want to get the length of the curve because we're going to use the actual values here to calculate some stuff later. And what we're going to do is take the position of this sample and plug it into here, and then we'll plug this into here. So we'll get a little point. I can make it bigger so you can see it. And basically what it's doing is it's sampling the curve at the point at which the curve has a length of 0. So at the very, very beginning, right here at laser start, right here, this position on the curve is being fed through to the point. As I move the length up, it's going to find a new position based on, okay, well, what happens when the curve is this long? And you can see we'll reach a maximum length eventually and it'll stop moving. So our maximum length's around like 8.9, 8.6, something like that. So that would be the distance between these 2 points. So that's how that is working. Okay, now let's go ahead and instance, let's create the laser and then we'll instance it on this point. So we're going to create a mesh primitive. We're going to create a cylinder. There we go. Now let's go ahead and plug the mesh into the output so we can see it. And let's take the vertices down. We just need a few. So yeah, something like that's fine. 5 is good. We're going to take the radius way down so it's really, really thin. And that should be good. Maybe just a little bit more. And that's great. Yeah, okay, cool. Now we're gonna instance this object where this point is. So let's grab our instance on points node. Okay, so this is gonna ask for a point. So here's a group of points, just one point at the moment, but it could be more. So we'll put that point in there. And then we need the instance object, so which is gonna be our cylinder. So I'll take the mesh, plug it into the instance, and then I'll take this and plug it into the geometry. Now, nothing's really changed because you can see the length is still 0 and it's in the same spot that this was. So I can drag this up and you'll see our laser is now taking the place of that little point object. So again, Blender is looking at the details of this point and just putting this piece of mesh where it is. So if we had multiples of these, there's now 6 of these right on top of each other. They're all in the same spot because we're feeding the same position information. So anyways, that's the idea. Okay, so what we want to do next is orient this laser beam on the same direction as the curve, or as the line itself. So we're going to use this special node for this called the align. Go up to search. I'm going to go align Euler to vector. This is the magic node. Now it takes the tangent. So the tangent of the line is like, think of it as like the direction of this curve, like which way is it pointing at this particular moment. Like if it was a curved curve, you know, we would be sampling that curve, we'd be looking at different points in the length, and the tangent would change. You can think of it as like the handles. Like, you know, if you have a point on a curve and they have handles, the direction of those handles, that's the tangent of the curve at that point, right? So if it's a straight line and you put a point in the middle of it and have handles, those handles are going to line up with the line itself. So the tangent is always kind of equal to the direction the line is facing. So we can use that. We can take this tangent and plug it into the vector. And then what we can do is it's going to convert that over into a rotation value. So instead of a vector, which is pointing in space, it's going to translate that into a rotation. So we want to rotate along the X, Y, or Z. One of these, let's find out. I'm going to plug this into the rotation and then let's just click through until it points. Yeah, great. There we go. Now you can see wherever we go, it's going to be aiming correctly. And then we can take the length and you can see it travels. Awesome. It's looking cool. All right. Now, next thing we need to do is to have it kind of disappear. So we want it to start here, right? And we want it to be basically invisible and kind of emerge out from the origin of this, you know, laser start point. And when it reaches this one, we want it to kind of disappear into it. So we have an emergence and a disappearance that we need to kind of create. We're going to use some scale values for that. But let's think about this kind of in isolation. Let's not look at the curve and everything, right? What we want to do is basically scale it up and down. I think that's going to be the best way to generate the effect that we're after, okay? So in order to scale it, at the moment, if we go transform, create a transform node and drop it here, and if we scale it on the Z, you see it's going to kind of like move into the center, but that's not really going to work because we want it to we don't want it to like emerge from the center out. Like I'll show you here what I mean. If we go this into the instance again and we take this back over here, if I take the scale and I scale in Z, it's not really going to work if it's like growing out like that as it's moving. You know, it's going to look a bit weird. We kind of want it to like be right here, you know, and scale out like that and then start to move. And then like from this point, scale into this point and disappear. So that's kind of what we want to have happen. So we don't want the scale point to be the center, if that makes sense. Hope that makes sense. You can see its scale point is the center. So we want to offset that. Now we can do that with the transform node. So by transforming this geometry before we use it as an instance, it's going to basically take it as it is when it receives it. So if I move this up 0.5 on the Z, and then I'll take our length back to 0, so we're seeing there. You can see it's moved it up. If I take it all the way up, should be all the way up to 1. Yeah, now you can see the laser, the tip lines up, or the end lines up with the start point here. And if I scale, you can see the origin is now at that point in it. So it's kind of a good tip. You can take some mesh, create some mesh, and then change it a little bit before feeding it in to get the origin right where you want it to get the kind of scale effect you might be after. Okay, now we need to do some fancy math. So we need to decide, first off, what's the distance between these 2 points? And we need to ask the question, all right, if this, if the length, so the position on this curve is greater than this point, that's when we need to be scaling. And if it's equal to this point up till the point where this is fully scaled out, then we need to be doing some math on the scale as well. So let's just kind of visually work that out first. So let's go ahead and get the distance, because I know we're going to need that. So we'll go vector math is what we need to do that, because the vector math node has a distance operation that it can use to calculate the distance between two vectors. So we can grab the location of our laser start and our laser end, and this will output a value which will be the distance between those. So this is going to be equal to the maximum length that we can get out of this. So this number should equal whatever this is, 111 point something. So, all right. And now let's figure out where it needs to go so that it matches. I'm also going to create a value node just so we can drive a few things at once. So we're going to drive the length with this, but then we're also going to drive the scale and these calculations. So let's see. I'm going to take this, and I think I can use a map range node to get this to work. Because when this is 0, right? When the length is 0, I want the scale to basically be 0 as well. So I want them to equal each other. So this is what it's going to be like. And then as this number goes up, I want this number to go up as well. Is that right? Is that going to work? I want it to go down. Yeah. Because I want it to go negative. So I want it to go like that, basically. So that as this goes up, up, this goes up, up, like that. And they kind of stay in sync. Now, I know that -1 is where it's going to be at its maximum length. And that will be right about here. So when this is at 2, this should be at -1. So I think we can use a map range node to do this kind of a thing. We're kind of sliding these two things together. So maybe so it's simpler. It might be nice if instead of going negative, we went positive. So I think I should just flip this. I'll take this down to -1. So that should do it. So as this goes, this is what we need to be doing. Yeah, cool. That makes a little more sense in my brain. All right, so let's create a map range node, and I'm going to drop it here, and I'll take the value and I'll pop it into the value. And what I want to say is we're going to, so 0 is going to be 0 when this one is 2. And the reason for that 2 is I think it's because, yeah, the depth is 2. So when the length on the curve is equal to this number right here, like we could even drive this with a value. If I set this to 2, I can plug this in here and we could say this, right? So when it's equal to the depth of the laser, so the length of the laser, then what we want to do is set this 0 to, yeah, we want the scale to be 1. So I should be able to just plug this in. Oh wait, we need to make a vector out of it, because this is, you see this gray output? This means this is a floating point number. This purple input means it's looking for a vector of 3 numbers. So we need to create one. So let's go combine X, Y, Z, and we're going to take this, plug it into the Z. We can keep these at 1. I clicked and drag, by the way. You click, drag down to select multiple boxes at once. And I'll plug this into the scale. Okay, now let's test it. Ready? Whoa, check it out. It works. Pew, 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 pew. Okay, now we need to solve the other end. All right, so when this thing is equal to the length, so when it's equal to the distance between these, from this point on, we need to start scaling. We don't need it to move anymore. We just need the scale to go down. So let's get a math node, because math nodes have a greater than or less than test. So we can plug this into the value, and we can say, oh no, plug that into the threshold, and we want to take this into the value. So basically, when this number is higher than the distance, we want to, this will become 1. Before that, it'll be 0. So we can use this to kind of multiply some values to cancel stuff out. I hope this isn't getting too hairy. Hope you're following along. Let me know in the comments if I'm doing a good job explaining. Also, let me know in the comments if I'm doing a bad job. That's really what the comments are for, aren't they? Let's be honest. So we want to be, the next thing I want to do is I want to subtract. I want to subtract this value from the distance, so that the more we get away from the maximum length. So the higher we get from the distance, the higher that number gets. I want to take just sort of the amount that is above the distance and beyond and use that to scale, literally scale this thing in. So we need to get that value by subtracting these two. So this one will be greater than this one. So this will give us a positive value. Greater minus the smaller means we'll get a positive value. And what we can also do is we can go ahead and create a multiply and plug this in and this in. And what this is going to do is basically when this is less than the distance, right? This is going to be 0. And so by multiplying the subtraction by 0 means that we're basically just turning it off. It's not going to give us any results. It's just going to give us 0 until this is greater than the distance. And then this will be 1. And so multiplying 1 does nothing. And so it just passes the value through, which is cool. Okay. So, could also just clamp it. I guess it'd be exactly the same. We're going to map range this one as well. So this map range, take this value, and this one's going to start out really small and it's going to get bigger and bigger and bigger. And then when it hits, is this what I want? I say when it hits 1, I don't want it to go above 1. So I'm pretty sure clamp will take care of that. So yeah, so let's create one more math node. This one we're going to have subtraction. So basically we create this first scale, and then from this value, we're going to subtract this value. So as this one grows, we're going to take away the scale. So I'll pop this here, and I'm going to click clamp. And now I think as I do the length, let's just check. Here we go. As we go in, yeah, cool, it worked. Ah, nice. So you can see we're going in and disappearing, and this works no matter like where this thing is. So it could be really far and it's going to work. It's also going to not matter how long the laser is. It's going to still, nope, doesn't work properly. All right, so we need to figure that out. But oh, it's because this transform is based on this. So we would need to have another math node, right? We need to go math, and then we would need to divide by 2, -2, and plug that in. And then that should be, oh, then we would need a combine. Sorry, this is just combine X, Y, Z. And then that would go into the Z, and then both of those would be 0. And then that becomes the translation, so that if this gets bigger, it's now going to work like we expect it to. Yes, cool. So the next thing to do is to have some sparks fly whenever it hits something. So what we need to do is set up a little spark system. So let's do that. I'm going to come over here, and I'm going to base all this off of a UV sphere. Okay, so I'm going to have a little UV sphere, and we're going to put points on that sphere and like mess them up and kind of scale them out. Using a similar kind of method to what we've done here to control the scaling based on its position and how close it is to the end of the line. So we'll start over here. We're gonna put this UV sphere wherever our laser end is. So the laser end empty is where we're gonna put this thing. So let's grab a transform node and we'll plug the mesh in for that. Bam. And then what we're gonna do is translate it. So we're gonna take translation. We're gonna grab laser end, grab its location, and grab its location and pipe it in right there. So now the UV sphere is here. And I'll just show you. I'll just plug this in so we can actually see what's happening with what we're making. So there we go. So wherever this end goes, this sphere will stick with it. Now, next thing we're going to do is we're going to instance some points on this geometry. So we're just going to go a mesh to points, I think. Yep, mesh to points is the node. So click there, and now we've got a bunch of points on the mesh, just like so. And now we're gonna like mess them up a little bit and move them around and do some cool stuff. So we want to have them like, kind of move out right when it hits. We're gonna do that with some scale. We're gonna scale up these points. Well, not scale them up. We're actually gonna move these points in the direction of the normal, and that's the direction each face of this UV sphere is pointing. That's the normal. So the normal of each face. So we need to get that attribute and use that attribute to move everything. So if I go over here, I can create a set position node. That's the node for moving things. Now moving individual points, sorry. Transform is the node for moving a whole object, but to move just an individual like vertex or something, you want to use set position. And we want to be offsetting, but we want to know like what direction do we offset it? If we offset them all in the same direction, it's just going to slide around, right? We want to actually offset these guys each in different points, in different directions, and we want to use the normal to do that. And again, if you haven't seen a normal, it's just picture it as like a little arrow pointing out of each polygon. Which way is it facing? That's the normal. It's represented in sort of a -1 to 1 format. So it's a normalized vector on the. Never mind, this is getting too complicated, but it's fine. Just think of it as like the direction it points. So let's grab a normal. And we we're gonna do this kind of further down the chain, and we're kind of making some changes. I don't think we get them. I don't think we still have a normal by the time we create these mesh to points. I'm not sure. I don't think so. I want to get the normal from here, I think, or like from here, because I want it to be the normal of this UV sphere. So I'm gonna do the capture attribute node. I'm gonna drop it in right here, and we are gonna capture the normal. So grab the normal. And this will allow us to kind of use it wherever we want later on. So if I grab this, I can plug it into the value. So this is the value we're going to be capturing. I want to make this a vector because see, it's purple, and the vector means it needs a vector. So what this is going to do is it's going to go through every point on this UV sphere, and it's going to capture the normal for that point. Okay, so what direction is it facing? And by capture, I just mean it's stored in this node, right? And I can plug this into anything I want now down the chain, even if we make a lot of changes to this object. Because if you notice, this normal node doesn't have any input, doesn't have any information. There's no like drop down. You can't select what object you're actually referring to. So if I use this, further down the chain, it's going to be looking at the normal of like sort of the object at this point. If I plug this into here, right, it's going to be slightly different than it is back here. So this is sort of a way of going all the way back in the chain and saying, okay, I'm going to use this again. So let me go ahead and set this up. So I've got an output that I can grab from that refers to this moment. So hope that makes a little bit of sense. So, all right, now we want to kind of randomly jumble these points up a bit because we want this spark, to be like an even sphere. So let's grab a random value node, and we're going to grab a math node. And what else are we going to grab? I've got some other ideas, but we'll wait on those. So we want this random value node to affect how far it moves. We also want the normal to affect how far it moves. So we're going to use the offset here for set position, and we're going to multiply it by the normal. So let's use the math node. We're going to go multiply. And that's kind of how you use normals, by the way. You always multiply them by things. So actually, we need to be using vector math, not just the regular math node, because we've got purple and we need to be using those. So plug that in here, and we want this random value. We can just use we don't have to use a vector for this because it's going to generate one number, but it will, if you plug a gray socket, so a floating point number into a vector socket, it will basically take that one number and then use it for all 3 entries. And that's kind of what we want. We want like an even randomness. I mean, I guess we don't have to have an even randomness for this. We could use the vector mode and plug that in. That'll be fine. That'll create random numbers between all those, and that's probably good. Okay, so anyways, all that, and we're going to switch this to multiply, and we'll plug this into the offset. That will scatter those points. Now, we want to be able to kind of scale how big it gets. We could probably use this. So if I click and drag down, I can grab all of them. This will allow me to kind of, affect them. Like how's it look? I'm going to take the radius of our original UV sphere, and I'm going to bring it right down. I could make it 0. I think 0 is going to be okay. Having it 0 means that these guys scale all the way down. We're not going to see anything. I think let's instance something on these points. So let's go instance on points. We'll drop this here. And the instance we're going to do is we're going to use a cylinder as well, another cylinder, but we're going to use these sort of like little streaks of sparks. This is kind of the effect I'm going to go for. So let's grab a cylinder, and I will plug the mesh into the instance, and I'm going to take the radius right down so these guys are really narrow. Take the depth down as well because they don't need to be super tall. So we got that. Now we need to align them right into the direction they're facing. So let's grab the align node again, the align Euler to vector, and we'll plug this into the rotation. And we need to get a vector, and this is a good case in point of like if I grab the normal node, right, and I drop it in as the vector, and I set this to Z is probably what it should be. You can see it's not working. It's not actually rotating them in the direction we want. It's because all these points, right, they don't really have a normal anymore. They're just kind of always straight up and down each point. That's why we need to go back to this and grab this attribute and use that. And now we're going to get a result that makes a little bit more sense. These guys do look like they're pointed in weird directions, but maybe it's because we're using the vector. That's why, because they're all going to be pointing in different directions. Yeah, that's what's going on. So if I make this 0 again and then plug that in here, we're going to get random distances. Yeah. So if I grab a math, yeah, what does this do? If we add, it just moves them out. Yeah, cool. So this will be the value that we use to drive their motion. Let's try that. Let's grab a value node and we'll plug it into both of these, the max and the value. So we're like changing the random seed and adding at the same time. I think that'll be good. That'll give us sort of one controller for the whole thing. That looks quite nice. Now, one thing that we are going to want is, right now, like every time the sparks goes, right, it's going to be the same pattern. It's going to be the same sparks in the same spots. So we want to roll this seed somehow so that we get different positions, right? The frame range. So like as the playhead moves, so as we hit play, like every 20 frames or something, we'll have it change. Because like you figure with the laser fires, it's going to hit, boom, and then another one's going to fire, and that one's going to hit. There's going to be a couple of frames in between those. So maybe 5 frames, maybe, be cool. Something like that. So we grab a value node and then we could use a driver. So I could click here on the number and just type the pound symbol or the hashtag, right? And then type in frame. This is the shorthand to get a driver that gets the frame range, right? If I edit the driver, you can see it shows us, this is like the full driver setup and the expression is frame. That's a built-in variable in Blender that always accesses the frame number, the current frame number. So we can use that. And then what we can use is a math node that sort of, because we don't want to change it every frame. We want to trade it like every 10 or every 5 frames. So what we could do is go snap as the function. We can plug the value into the value and we can say, all right, what increment do we want to snap to? Let's say 5. So every 5 frames, it will change, it'll go up. And we can plug that into the seed. Probably now if you watch when we press play, every 5 frames, it's going to change. Okay, so we're going to use a map range, I think, again, because we want to go back to all the way over here, this value, the thing that's controlling our laser movement. We want that, as it continues past where the laser goes, we want that to drive the expansion of this thing. So we are going to grab this map range area. We want to use the one that's here that's sort of after these subtractions and stuff, because remember, when it's greater than, that means it's past the point where the laser is going to stop. And so every value beyond that is what scales the laser down to 0, but also could be great for us to start using when that number starts going up. We could use that to drive things like this expanding. So we'll end up using a map range again, I think, to kind of change the boundaries of that number, like to either scale it up or scale it down. But for now, let's just use it straight out of the gate, and let's just see where this is all plugged into. So those two. So I'll grab this and I'll plug it into the max here. And I'll grab this and plug it into the value. So now you can see when at the beginning, it's not going to do anything. But then when it passes the distance, it'll start to scale up. And it scales up only to a certain point because we've got clamp turned on. If we turn off clamp, this will continue to scale up like that. I don't think that will affect this because we've got clamp set there. So that's what we want. Now we just need to set a range for like where do these sparks need to disappear, and we will scale that range as well. So let's go ahead and join this all up. So I'll bring my output way over here, grab another join, not strings, join geometry, join geo, and we'll plop it there at the end. And then let's go find, here's the output we want. So plug that one in right over here. And now we've got all the things together. The laser, bam, there you go. Except these sparks are very tiny. I think they're a bit too small. Okay, now we got to decide how far do we want these guys to go. We should also have good materials on them so we can see what it's actually looking like. because in this environment, it's going to get kind of tougher and tougher to kind of work out exactly how good the proportions are. So let us, I'm just going to save. Now I've got some materials here. We'll make them fresh. Let's go to my laser system because you have to have a piece of geo selected to create a material. And we're just going to click new and creates a new material. We'll call this first one the laser material. We'll just scroll down to emission. We're just going to brighten it up and we'll go kind of a little off red. I think we're going to go for red lasers. And I will turn the strength up to 10, let's say. And then I'm going to come over to my render settings and make sure ambient occlusion, bloom, and screen space reflections are turned on. Now we don't have anything that's going to do ambient occlusion at the moment. Likewise, there's nothing reflecting anything, so this is kind of redundant, but we might add those things later. So I like to go ahead and just turn them on now. We definitely want bloom though. That's going to make things glow using EV. So got all that turned on, laser, blah, blah, blah. All right, so we can come over here and now we can set a material. Set material, and let's set the laser to be the laser material. We go ahead and go into render view. Now we can start to see this. Now we need to create another material. Now we can actually get rid of that. So minus it off of this piece of geo. It still lives in our scene. So you can see there, laser is still here. We can click this little shield to protect it so that it doesn't get deleted from our scene when we close. And then you'll get this little F next to it, which means fake user. So it's like assigned a fake user to this, so it won't get deleted. These ones with the 0 next to it, these older materials, these will get deleted when I save and quit Blender. It's just like a little cleanup that Blender does. Any material that's not assigned to anything, it'll just get rid of it. Unless you click the shield. So good tip. All right, now let's call this sparks. And we'll go down to the emission. And we're going to make this kind of just like a white. So I'll just drag it out. Might go a little bit yellow. And we'll turn the emission strength also up to about 10. And then let's assign that. So I'll Shift-D this set material node right here. And we're going to grab sparks. And so now we've got some sparks. So see how this looks. And we can start identifying what's next. So we've got the laser, it could fire. And then the sparks go. The sparks are good. Looks really nice. Now, of course, we do see them this whole time. So we need to get rid of them. And then we also need to have a point at which they disappear. And yeah, but I think overall this is looking really nice. And our laser end, we can drag this out. It's kind of cool that if this close, that's neat. That's cool. Oh, wow, look at that. That's a wild effect. If it goes to the other side, is basically when this is 0, we need to have the scale of these guys be 0. So we can have that affect this bit over here. So we've got this combine X, Y, Z, blah, blah, blah. We're going to here. So here's our scale. So let's go for a vector math. And we'll just drop this here. We'll turn this on to multiply. You can see they disappeared because we're multiplying by 0. And I just kind of want to test, is this greater than or less than 0? So let's grab a math. And we're going to go for, let's see, greater than. And I'll drop this here. And we are going to test. I don't want it to interrupt this flow. So actually, I won't drop it there. I'll just grab another pipe out into the value. And the threshold is going to be 0. I just want to know, is it greater than 0? If it is, then it's going to be 1. And it'll multiply the scale here by 1. So it won't change it. It leaves it the same. So it'll just pass through. Whereas if it's less than or equal to 0, this is going to be 0. So it'll be multiplied by 0. So it won't actually work. So you'll see as the laser hits, they will appear. Wow. Now we need them to disappear. So how long do we want this? Probably, I don't know, like to about there, wherever that is. So when this value hits like 45, let's say, over a certain threshold, we're going to start scaling them down. I think that's what we'll do. It's the same kind of thing that we were doing with the other one. So again, we're going to affect the scale of these instances to do that. So we've got this check for whether or not we've even reached the laser yet. And now we need another check for if we reach a certain threshold and start scaling them to 0. So we're going to be subtracting from the scale till we hit 0. Okay. So let's see. We'll get another greater than, and we will test this value and we'll say, okay, are we over, we'll say the number 40 to start with. Are we over the number 40? If we are, then let's multiply this value by whatever it is we're going to be doing. Because if it's less, it'll be 0. I guess we're going to manually set the threshold. So we could just subtract whatever this number is by the threshold. So if I grab a value node, we'll set this to 40. And I'll use this to drive this number, but then also I'll use it to, so we'll go subtract that from that, because it'll be greater than 40. So that means this will be the bigger number, so that minus that, so it'll be a negative. I'm going to swap these so I get a positive number. And then I'll pop this through here. So this will be our gate that turns it to 0 or lets it pass through. And then we're going to subtract from the scale. So let's get a vector math node. We'll drop it here. We'll set this to subtract, and we'll plug this into the value. We'll see if this works. I don't know if it'll work, but I'm assuming it will. All right, so something's happening at this point. You see they start to get really big? There we go. So we've got something flipped, obviously. Just need a clamp. That's all we need. We just need a clamp. But that's not going to be the right spot for it, is it? Oh, yeah. No, that works. So now that we've got this kind of working in the system, what I'm thinking is we want to have it set up so that it kind of continually goes, right? But probably don't want it to be just a consistent bop, 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 like every time it completes the cycle, it immediately starts over again. It'd be nice if there was some variation in the lasers, so like different like pauses afterwards. So let's figure out how to do that. The first step would be we want to have it kind of repeat on a cycle. So at about 50, that's the point at which I think it's pretty much completed the whole thing, right? So what we could say is when we hit 50, we want to start over back at 0 again, right? We want to reset this value to 0, and then we want it to play forward. And we want to just go at a constant pace, right? So to do something to go back and forth between those numbers, what we need to do is we need to feed it a value that's constantly going up, so we can use the frame counter. So when you hit play, the frame counter just constantly goes up. And then we need to use a function called modulo. And what modulo does is it takes a number and another number, and it goes, all right, whenever this number is over the second number, it resets back to 0, and it starts counting back up again to the first number. So that's going to be in the math section. You can see I had it there already. So if I come right here and go math, and we switch this from add, just zoom in here, we can go over to modulo. There it is. So with modulo, we can set the value to 50. And then we're going to have this thing loop through. But we need to kind of hook this up a bit better. So let's go ahead and I'm going to get a reroute node in case we want to put other things over in between these. This will just make things a little bit easier for us, a little bit cleaner. So I'm going to, how do I want to do this? I will grab each of these bits one by one and plug them into this reroute. Just want to make sure I get all the right ones. There's that one. Got this one right here, and then we've got this one right over here. There we go. So if I plug this in now, and we set this to pound frame, I'm going to allow execution of, oh, that didn't work. Let's try that again. Delete driver, because I had caps lock on, didn't work. So hashtag frame. Now I'll have a constant frame, and I'll drag out my timeline so it's past 50, and you'll see if I hit play, the laser is going to continually go. As soon as it reaches that 50 point, it resets and does it again. Now it's a bit too slow, so we need to speed this up. So instead of frame just by itself, I'm going to go frame multiplied by 10. That looks about right. A bit more laser speed. This is too quick. Let's slow this down a little bit. Instead of 10, let's try 5. Now that laser feels too slow. We gotta get the speed feeling right. So let's try 8. Yeah, that's kind of nice because you can actually see the blast travel. With the sparks, that's way too quick. We need to slow those sparks down. So how are we gonna do that? Well, let's come over here to the bit that controls the sparks. And it's going to be, where are we? Set position, offset, multiply, add. So this bit here is what's controlling, how quickly they go. We've got the random bit, remember? And then we've got this bit here, which we're adding from this. So we need to take this map range and we need to change it a little bit so that it's a greater range, so that as this number goes up, it just kind of slows everything down so it's not moving as quickly. So I'm going to Shift D to duplicate this map range, and I'm going to drop it right here. And what we need to do is we need to find a frame where we've got the sparks. There we go. And we need to slow it down. So as it gets to 1, we want this to have only traveled a little bit. So like 0.1. That should slow things down. But we're going to need to expand the modulo function to go higher. So let's turn this up to 500 for now, so we just get a huge number. And then we can figure out what this needs to be. All right, so this is going to affect a lot of things, isn't it? It's going to kind of ripple through. You can see as this number gets smaller, they kind of like, this is where it should be, right, at 1. And as we bring this down, they're getting closer and closer in, right? So going to 0.1 is really going to slow down the system. So this one's okay, because this is the initial beginning. So it doesn't appear, but with the right, beforehand. So it's just these that we need to replace. So if I pop that into the value here and this into the value here, oh, that's what happened. This got messed up. This doesn't want to go to that. This needs to be to that. These need to be flipped. Yeah, there we go. Now they're disappearing like we wanted. Sweet, and there we have it, a fully functioning laser system with sparks when they hit. Very cool, using geometry nodes. Hope you found this tutorial helpful. If you did, hit that like button and leave me a comment. Let me know what kind of tutorials you'd like to see in the future. And please subscribe to the channel and ring that bell to find out when new tutorials drop. Thanks so much. I'll catch you in the next one. Until then, have a fantastic week. See ya.